In this video, I'm going to work out two examples of multiplication rule number 1, in which we multiply the probabilities of events that are independent. The first example says the following. 2 dice are tossed twice, and a sum of 7 occurs both times. These events are independent, as getting a sum of 7 on the first toss does not affect the chance of getting a sum of 7 on the second toss. Compute the probability using multiplication rule number 1. Whenever we compute probabilities involving dice, they're always going to be independent because we cannot physically remove one side of the dice. So the probabilities will remain the same for each trial. And the probability of getting a sum of 7 is 1, 2, 3, 4, 5, 6 possibilities out of 36. So on the first toss, it's 6 out of 36 chances. And that probability remains the same for the second toss. 6 out of 36. 6 out of 36 reduces to 1 out of 6. So it's really 1 out of 6 times 1 out of 6, which is 1 out of 36. And that's going to be the answer. Now we could also apply this rule whenever we're selecting a sample from a large population. We treat those events as being independent because we're only picking a small sample and the changes in probability from a large population are negligible. So in this example, it says the following. A study has determined that the chance of passing statistics at a local college is 78%. If 3 students are randomly selected, what's the chance that all 3 pass statistics? Round the answer to 3 decimal places. While we're only selecting 3 students from thousands of students, these would be considered independent events, meaning the probabilities will remain the same for each trial. So we have the first student has a chance of 0.78, second student has a chance of 0.78, third student has a chance of 0.78 of passing the class. That's the same as just taking 0.78 and raising it to the third power. And we can use the calculator to perform that computation. So we type 0.78 and we have a power button. Select here on the power button. 3. It's 0.47. This will round to 0.475. So that would be the chance that all 3 students pass statistics. Thanks for watching the video.